All right, guys, so let's start with the chapter 2 test review, part 2. So let's look at question 34. Given P and Q as below, write the statement P implies not Q. So that means my P is just my what? Hypothesis. And my Q is my conclusion. But what am I doing to that conclusion? What does this sign mean? This sign is a negation, which means not. So I need to write if P, then blah, 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 not Q. So if my sentence does not look like that, then I am not doing it correctly. So let's look at my first hypothesis, or my hypothesis, my P. Measure of angle A equals measure of angle B. So that means my first part of my sentence, my first portion has to say if measure of angle A equals measure of angle B. So let's cross off anything that does not say that. A does not say that. B does. C does not. D does. Look at E. E is doing what to this hypothesis? It's negating it. Did I negate here? No, I didn't. So that one is not an answer. So we can negate that. We can get rid of that. And if A is congruent, no, that's starting with the conclusion. So now I have two choices. So now my second statement, my second portion of the statement, my Q, A is congruent to B. In order to write it in this statement with this format, I have to negate that Q. So this should read, then angle A is not congruent to angle B. And that is this one. So the answer is B. Now, we should all know what our statements look like, correct? We have, first, we have the conditional, which is if P then Q. We have our converse, which is if Q then P. We have our inverse, which is if not P, then not Q. And then we have our contrapositive. I'm just going to write contra, which is if not Q, then not P. Perfect. So given the name for the statement, Q implies P, give the name of this statement. So here we're assuming the first one is P implies Q, which is the original conditional statement, so that's fine. So if P then Q, if this is how I started the conditional, what is this? This is the converse, which is right here, okay? You guys should already know that, right? So let's look at this next one. Give the name for the statement. If not Q, then not P. That is the contrapositive. Okay? So this one's a little bit harder. So let's do it together. Let's do it. So use symbols to write the statement that is equivalent to the statement if not P, then not Q. So if we take a look, we just had previous, right? So we just had that we just give all four of our statements, right? So if we look back, because I don't want to rewrite it, let's look here. So we know that the inverse is the negation of the conditional. And we know that the contrapositive is the negation of the converse. We also know that the converse and the inverse are what of each other? They're equivalent statements, which means if the converse is true, the inverse will always be true. If the converse is false, the inverse will always be false. What else are equivalent statements? The conditional and the contrapositive. So now that we know that the conditional and the contrapositive are also equivalent statements, let's see if I can crop this out just so I don't have to write it again, because that'll take a while, right? Well, I guess it's not going to work. Nope, okay, whatever. I guess it works sometimes. So this is if not P, then not Q. So this looks like what? Let's ignore this negation right now. This if not P, then Q, this looks like the if P, then Q, which is my what? conditional. And what did we just say is the equivalent statement of the conditional? Well, that would be the contrapositive, which looks like what? If not Q, then not P. So let's see what steps I had to do, because to go from the conditional to the contrapositive, what did I have to do? I had to do two things, right? I had to switch the hypothesis and the conclusion, and then I had to negate both of them. So let's take our original problem right here. If not P, then Q. And let's apply the same processes we did here to go from here to our answer, whatever that answer is going to be. So what was the first thing? We switched the P and the Q. So let's do that here. So let's just switch both of these, right? So my next thing should look like this. Cool. Now, what was the next thing that we did? After we switched the hypothesis and the conclusion here, we did what? We negated both of them. So now let's negate both of these guys. So the next step should look like not Q implies, what happens when we negate something that's already a negation? We just get rid of it. So now that's just going to be P. So this is my final answer, which is right here. This one's hard, so please review it and ask questions. Go to tutoring if you need, please. Okay? So let's look at this one. Use the hypothesis and conclusion given below to write the inverse statement. The inverse statement is the negation of the conditional. So I'm going to write, it's going to be, the inverse is if not P, then not Q. So I'm just going to negate this P and this Q and put them as a statement, right? An inverse statement. So it should read, if a figure is not a quadrilateral, then the figure does not have four sides. So that is C. If a figure is not a quadrilateral, then the figure does not have four sides. Okay. What about the next one? Same thing, but instead I want the contrapositive. Contrapositive is if not Q, then not P. So let's turn this into a contrapositive statement. So we start at the Q now because we start at the Q. If the figure does not have 10 sides, then the figure is not a decagon. So the answer is C. If a figure does not have 10 sides, then the figure is not a decagon. So now we're going to start doing law of detachment. Remember, with law of detachment, if my P to Q is true and my next statement starts with P, my next conclusion must also be this Q. So with law of detachment, my second statement has to start with the hypothesis or the P. With law of syllogism, my second statement has to start with the conclusion or the Q. So let's see if we can use, if possible, use law of detachment. So let's see if we can use law of detachment to make a conclusion, to make my Q, this next sentence that should go right here. So what is the P? If a triangle has base 7 centimeters and height 2, so let's write P here, then it has an area of 7. So area. So now let's look at my next sentence. My next statement, triangle ABC has an area of 7 centimeters. Wait a minute. This looks like the Q, which it is, area and area. So can I use law of detachment in this format to create a true conclusion? No, I cannot. No. Why not? Because the hypothesis given is not the same as the hypothesis of the given conditional statement. So it's saying that this hypothesis is not the same as this original hypothesis. So no, I cannot. What about number 41? If possible, use the law of detachment, make a conclusion. If not possible, tell why. So we just did this, right? So let's see if our second statement starts with the original P. So if 3 points are not collinear, so 3 points are not collinear, that's my P, then they form a triangle. Forming a triangle would be the Q. So if 3 points are not collinear, then they form a line. So let's read the next statement. Points B, C, and D are not on the same line. That is the same thing as my P. The only reason why it looks a little bit different is because they're phrased differently. So look at this P. If 3 points are not collinear, the next statement says points B, C, and D. Aren't points B, C, and D just 3 points? Yes. And if I say if 3 points are not collinear, isn't saying not on the same line the exact same thing as saying not collinear? Yes, it is. Therefore, I can actually use the law of detachment. It doesn't need to be the exact same print, copy, and print sentence as long as it is the same principle as the original P. So now my sentence, my conclusion, I should say, how I finish my sentence, my conclusion should be some answer of these points, B, C, and D, forming a triangle. Why these 3 points? Because look at this key word. Then they form a triangle. What is they in this situation? The 3 points that are not collinear. And what are the 3 points that are not collinear here? In this second statement, it's points B, C, and D. So my answer is the conclusion is the points B, C, and D form a line. Okay, so that one's a tricky one. That one's on your test too. So if possible, use the law of syllogism. Law of syllogism, we know, looks like this. We need to have a P and a Q. If that's true, and then I have a Q implies R, that's also true, then I can cut this Q middleman, right? And just make the true statement of P implies R. What's important is that you have to be able to start with both. You have to be able to end with the Q on the first statement and start with the Q in the second statement. That's what's important. Okay, so let's read. If Melanie works overtime, so if Melanie works overtime is the P, then she'll get a big paycheck. That's the Q. Let's look at the next statement. So my next statement has to start with the Q. So if Melanie gets a big paycheck, perfect, big paycheck, then she can pay off her credit card. That would be my R. So since my Q and my Q are the same thing, I can cross those out and make the conditional statement, or a true conclusion, I should say, of if Melody works overtime, then she can pay her credit card, which is what C is. Okay? So let's look at the next one. Okay. Make conclusions from the following statements. So note which law you use to make a conclusion, the law of detachment or law of syllogism. So if you're studying zoology, then you are studying biology. If you are studying biology, then you are studying science. Is this the correct use of law of syllogism? Yes, it is, because I started with my Q on the second statement. That's what's important. You're studying zoology. Okay, my pencil just, okay. You're studying zoology is my P. Studying biology is my Q. So if I start my second statement with something of zoology, I know I need to use law of detachment. If I start with something of biology, I know I need to use law of syllogism. So this is Q as well, and then science would be my R. So now I can cut this off and just say, if you are studying zoology, then you are studying science. And that's what I have here, and it's law of syllogism. So we're gonna start 2.6. So remember 2.6 talked about different properties, right? Reflexive, symmetric, and transitive. So let's fill in this blank. The statement, if measure angle 1 equals measure of angle 2, then the measure of angle 2 also equals the measure of angle 1. That is an example of the symmetric property. Remember, the symmetric property is setting two things equal to each other, but they're actually different things. Reflexive would look like this, right? Measure of angle 1 equals measure of angle 1. That's reflexive. Okay, so let's keep going. The statement, if measure of angle C equals measure of angle D, a G, and measure of angle G equals measure of angle Q, then measure of angle C equals the measure of angle Q. That sounds a lot like the law of syllogism, right? So remember, the only difference between syllogism and transitive is that syllogism, we start with S, so we use these for sentences, right? Transitive, we use it for numbers, angles, segments, things like that. Okay, so now remember when we're talking about those 2 column proofs, you're gonna have to have the 2 column proofs as well as be able to give your statements and or reasons. So this first statement was given to me, cool. So now let's fill in the blank. What did I do from this statement to get to here? I did what? I distributed, right? So distributed property. Now from here to here, I did what? I subtracted 6 from the left side and from the right side. When I subtract or add or divide or multiply things from one side of the equation to the other, that is called, in this case, it'd be subtraction. So that's subtraction property of equality. You have to put that of equality. If not, it's wrong. The next one, we did what? We divided by 3, divide by 3. So we did division property of equality. Here, let's take a look at this one. Okay. Fill in each blank with a reason that justifies the statement given xy equals 70. So I'm just going to write that here, that this whole xy equals 70. Okay. So how do I know that xz plus zy equals xy? So let's look at xz. What is xz? Xz is this. What is zy? Zy is this. And what is xy? This whole thing. What do we know about when I take one segment and add it to another to create a whole bigger one, the whole thing? That is the segment addition postulate. Okay? So now, how did we go from the segment addition postulate to all these numbers? Well, pretty much what I did, right, is I took, let me put this smaller. I took this xz, okay, let's make it even smaller. I took this xz that has this value, right? I took this zy that has this value. And then I took the xy, which has this 70 value, right? Because they gave it to me. And what did I do? Instead of having xz, zy, and xy, I just substituted these numbers. So my B, my reason, was the substitution property. Now I do distributive. I combine like terms, 3n plus 5n, 8n. I subtracted 6. So what is that? Subtraction property of equality. Then I divided by 8. That's division. Okay, so we should know how to do these, right? Next one, super easy, right? Name the property of equality or congruence that justifies from the first statement to the second. This is symmetric, right? HL, LH, that's symmetric. So guys, very important. This is super important. This means that it's symmetric property of what? Congruency. If you put symmetric property of equality, right? If you ignore these things and you put of equality, you will get it wrong. So there will be a lot of people that will not know what to do, this or this, and they'll get confused. Make sure you're reading the last word, okay? Okay. Identify the appropriate property that describes the following statement, okay? If LM equals PQ and PQ equals RF, then LM equals RF. That looks a lot like law of syllogism, right? Wouldn't this be my P and this be my Q? And then, well, if PQ is my Q, then isn't PQ also my Q? And then my RF would have to be my R. This looks a lot like law of syllogism, but we know that law of syllogism is with sentences, so this is the transitive property. Okay. So, use the reflexive property to complete the following statements. So I just have to repeat the exact same thing, right? Angle QFT. That's it. So another proof. We did this in class, right? So write a 2-column proof to prove the following. We were given that ray AC is the angle bisector of angle DAG. So I know that this ray AC is bisecting this entire angle. And what happens when I bisect an angle? I get 2 angles now that are of equal value. So now I have an angle of DAC and an angle of GAC. So now let's see if, so now let's take a look at the actual chart now. So how did I know that angle AC is the angle bisector of DAG? DAG? Well, it was given to me, right? Next, how do I know that DAC is congruent to angle CAG? We just said that. Isn't that literally what an angle bisector does? That is the definition of an angle bisector. Now, if two angles are congruent, then their measures are what? Equal. So congruent angles have equal measures. We should all know that. Now, I'm just going to take the numerical values and substitute it into these angles, right? So 10x equals 7x plus 12x, right? Now, that's substitution property, right? I just substituted these values for these angles, for the measure of these angles. Now, how did I go from here to here? I had to subtract 7x. If I subtract across the equal sign, that is subtraction property of equality. And now, now that I know that x equals 4, what did I have to do for that? Division property of equality, because I just divided by 3, Okay? So now, same thing. We did this one in class, right? So, write a two-column proof. So, all that was given to me was that Km is equal to 39. So, Km is equal to 39, that's given. Now, if I know, I'm gonna cross these off, okay? Okay, let's try to, pretend like we don't know the answers, right? So we're gonna erase them as we go on. So now, if I was just given this, KL plus LM equals KM, what does that look like to you? KL would be what? KL would be this, no? And LM would be what? This, right? And Km is this whole thing. What does that look like to you guys? That is the segment addition postulate, right? So now instead of giving us the statement and asking us for the reason, they gave us the reason. So what's the statement that it had to have been? We substituted something, right? We substituted something from steps 1 and 2. So we substituted something from step 1 and step 2. Well, in step 1, they gave us that Km is 39. And now this box is empty. So what does this box have to be? Well, isn't it just this Km, which is 39? Right? So now, the next step, if we keep going, okay, now we have that they gave us this, they gave us these things, which they also gave it to us here in illustration, right? And now, the next one, how did we go from this to 2x minus 5 plus 2x equals 39? Well, what do we know here, guys? This says KL plus LM equals 39. So all I did was take the values of KL and the values of LM and plug them into this equation. And what is that called? When we take values of something, a numerical value of something, and plug it into the variables, we call that substitution property. Now, we're going to combine like terms, and we combine like terms, we're going to get 4x minus 5. Now, now they gave us that we had to do addition property of equality. So all we did was just add 5 from this side to this side, right? Now, knowing that we did division property of equality, I'm going to divide 4x and 44 by 4, which is going to give me 11. And now, using substitution property from steps 4 and steps 8, well, let me highlight this because I don't want to keep. So if now I'm locked into step 4 and step 8, because they told me I had to use steps 4 and 8, what did I substitute onto there? Well, my 8 had an x, right? So that x, where did I substitute that x into? Well, 9 is asking me for KL. So that means this 11 had to be substituted onto KL. And what's the value of KL? 2x minus 5. So the answer is 2x minus 5 was 2 times 11, 22 minus 5 is 17. So KL is equal to 17, and now we've finally proven indeed that KL is equal to 17. Okay, so explain why the statements, hello? Oh, pen turned off again. Okay, explain why the statements segment LR is congruent to segment RL. Explain why this segment LR is congruent to the segment RL, and angle CBA is congruent to angle ABC are both true by reflexive property. So ignore all this right now. Let's try to come up with our own reason, and then let's see which answer choices matches that. So we know that reflexive property is saying what? I'm taking this segment and I'm just changing the name of it because I'm still talking about the same exact segment. Or in this case, these angles, I'm talking about the same exact angles. So it has to be something of the fact that there are two different names to name the same thing. Or I'm just repeating the same exact thing. For the example of A equals A. That's an example where I'm just repeating the same thing. But saying segment LR and saying segment RL, that's the same thing. Saying angle CBA and segment and angle ABC, those are the same thing. So we got to look for something of two different ways to name the same thing, but they're still of equal value. So that is C, right? Since segment LR and segment RL are two ways to name the same segment, this looks really good so far, and angle CBA and angle ABC are two ways to name the same angle, both statements are examples of saying that something is congruent to itself. Okay? If we take a look at this first one, since the segment RL is a reflection, we've heard of reflexive, not reflection, so this doesn't make sense. Reflection, again, I don't know why they keep saying reflection. Since the segment RL is a reflection about the point R, this doesn't even, none of this makes sense. The only answer is C. Okay, this one's very easy, right? What true statement can you make about the segment length based on the diagram shown to the right? So what do I know about this DB and this BE? They're what? Congruent, because they have the tick marks. So, so the segments are congruent. Do they have any segments here? No, they have numerical values. So the segments are congruent, and if the segments are congruent, then I know that their lengths or their distances are equal. Okay? This is what do I know about this angle and this angle? They are reflexive angles. Reflexive angles are always congruent, right? And they mirror each other, correct? So this angle and this angle are reflexive. Vertical. And this angle and this angle are vertical angles as well. Vertical angles. Okay? So let's look at this one. Use the theorems and their definitions about angles to find the measure of angle 1. Well, I know that this entire angle right here is just how many degrees? 90. So if the whole thing is 90, and that 90 is composed of angle 1 and angle and 12 degrees, can I just say this is angle 1 plus angle 12 equals 90? Yeah. So minus 12, the measure of angle 1 is equal to 78. So my answer is 78. Okay, now we went over this in class. This is not hard, but it looks hard, right? So let's pretend we don't know these answers. Let's solve for x. So in order to solve for x, I have to figure out a way that I can set something equal, because in order to solve for a variable, I have to set it equal to something. So what do I know about this angle JKH and angle FKG? They are what type of angles? Vertical angles. And what do I know about vertical angles? that they are congruent. And if the vertical angles are congruent, then their measures are equal. So I can do 4x equals 84, divide by 4, divide by 4. That'll give me, what, 21, right? 21. So x is equal to 21. Now, if x is equal to 21, what is y? Well, I know that this y, let me erase this. I know that this angle y and this angle 84 are what of each other? They are supplements of each other, right? So that means that I can set this y plus this 84 is equal to 180. And the answer would be what, 96? If I subtract that? 96, so 21 and 96, so we were correct. Now, this one looks hard as well, but it's not. So, let's take a look at this one. Find the measures of the unknown angles. So, I don't really care about x and y, correct? So that's why it's important to read your instructions, because I don't care about finding x or finding y. I just care about the angles. So, let's take a look at this before the answer choices. FKG is how many degrees? 64. So then what is the angle JKH? It's also just what, guys? 64. I don't care about this right now. This is 64. Now, if this angle is 64, then what is y? Isn't this just a linear pair or adjacent supplementary angles, which is the same thing as saying a linear pair, right? So I can just do 180 minus 64, which is what, 116. So now if we go back here, let's shade our answer. So in orange, we're gonna shade JKF. So where is JKF? JKF, that is what? 116, and that is 116, okay? GKH, well, what is GKH? Well, if this JKF is 116, then GKH has to also be what? 116 because of vertical angles. And now last one, HKJ, that is 64. Good, 64. Now, this one is a tricky one, right? We did this one in class. So, given angle 1 is congruent to angle 6. So they gave us that angle 1 is congruent to angle 6. So that's why it's given. How do I know that the measure of angle 1 is congruent to the measure of angle 7? Well, wait, let me, because this is like, right? Because it's kind of spoiling it, right? Okay. How do I know that the measure of angle 1 is congruent to the measure of angle 7? Let's take a look at 1 and 7. These look like what? Vertical angles, right? Vertical angles are congruent. So now let's look at the next one. Using the transitive property of congruency. So remember that transitive property is if angle 1 equals angle 6 and angle 1 also equals angle 7, then I can just make this leap right here, that angle 6 is equal to angle 7. Because remember, transitive property is kind of like law of syllogism, right? Remember that for law of syllogism, I have this. This is law of syllogism. With words, with law of syllogism, with sentences, my Q has to be the conclusion of the first statement and the hypothesis of the next one. With transitive property, you do not need to worry about this order. So you know how law of syllogism looks like this? P to Q to Q to R, like that, like that. It doesn't need to be in that pattern for transitive property. If you have two of the same numbers, you can consider those like if they were your Q. So in these first two statements right here, what would be considered my Q? Well, it would be the 1, right? Because this shows up once and it shows up again. And this could be my P and this could be my R. So whenever my law of syllogism is correct, then I can just cut off the middleman and just say if P then R. So my answer is angle 6 is congruent to angle 7. So now let's look at the next one. How do I know that angle 6 and angle 4 are congruent? 6 and 4 look like what, guys? Vertical angles. So, vertical angles. Okay, and now, once again, how do I know that 7 and 4 are congruent? Well, let's take a look at the previous steps. I have 6 is congruent to 7 and 6 is congruent to 4. What does that look like? That's just transitive property, right? If angle 7 is congruent to angle 6 and angle 6 is congruent to angle 4, then I can say that angle 7 is congruent to angle 4. And that's what I get right here, transitive property of congruency. Okay? Same thing here, right? We have the same steps, so let's go little by little because I know this looks hard. So we are given all this information. We're actually given a lot of information, right? So A and B are supplementary, C and D are supplementary, A and C are equal. So let's cross off this because then it's not fun, right? Okay. So now we were not given the statement, but we're given the reason. Definition of supplementary angles. What does it mean to be supplementary? That a pair of angles add up to 180. So if A and B are supplementary, then measure of angle A plus measure of angle B has to be 180. And measure of angle C and measure of angle D also have to be 180. Now, how did I go from here to here? Well, isn't this just two statements? Yeah, this is A plus B equals 180 and C plus D equals 180. So aren't these two statements that I could use P and Q because they're the same and R? What is that an example of? If something is equal to something and that something's equal to something else, then what can I say about both of these statements here? That they are what? Equal to each other. And what's the property that we use for that? Transitive property of, is it of equality or congruency? What does it say here? This is what? Equality now. You have to put equality, okay? Now, how did I go from this statement to this statement? What's the only difference? The thing that looks different is the C and the A. So how did I go from C to A? Well, let's look up here on number 2, right? For number 2, they told me that angle A is equal, measure of angle A is equal to the measure of angle C. So if this and this are equal, what can I do? I can just take out this C and put a what? An A. I'm substituting an A. And I'm gonna move ahead. But why am I substituting this C for this A? Because I'm going to want to do what? Cancel out these two A's, right? So I know I just moved ahead, but so to go from step 4 to step 5, I had to do what? Substitution. And from here to here, I had to do what? I had to, remember, what is my whole goal? My whole goal is to prove that B is equal to D. So to go B is equal to D, I had to get rid of what? Get rid of these two A's. And how do I get rid of these two A's? By doing what? Subtraction property of equality. And that's going to leave me with B equals D, and that's what I need to prove. So I'm done. Now, this one is very simple, right? Okay. In the game of mini golf, the ball bounces off the wall at the same angle it hit the wall. So that means if this angle right here was 49, then what does this angle have to be? Also 49. And what do I know about these? And what do I know about the way that this ball hit? What do I know about this? These are 90 degrees. How do I know that? Because of the equal complements theorem, which tells me that this is going to be 90 and so is this. So now I can solve for x because I know 90 minus 49 gives me x, which is what? 41. And if x is 41, what is y? Also 41. Okay? Now, this one, we're going to go over it in class, but I'm going to go over this example right now. If A is 4 times as large as its complement B, then find each angle. Okay, so remember, let's compartmentalize this first. A is 4 times as large as its complement B. So that means that B is the complement of A, right? It's saying its complement. It's talking about A. So if A and B are complements, what can I automatically write? Measure angle A plus measure angle B equals 90. So now, 90 degrees, right? So now, whenever, can I solve for A and B at the same time? No, I cannot. They're two different angles, two different variables. I can't solve for that. So let's turn it into one variable that we can use to actually solve for and compare. So we want to turn one of these variables into x. How do I know which variable I want to set to x? You always set the smaller one equal to x, okay? So if A is if A is 4 times as large as B, as its complement B, then which one's smaller? The B. Because A is how many times larger? 4 times larger. So if B has a value of x, A has to have a value of 4x. And now I can just actually solve for this. Divided by 5, so my x is equal to 18. Now, we're not done yet, okay? Remember, they wanted the measure of A and B. So, what was the measure of B again? What did we use for B? We used x, which is 18. So my B is x. And what was my value of A that we said? My A we set equal to what? 4x. So what is 4 times 18? 72. Okay. Now, this question is very hard. This is probably one of the hardest questions. So find the value of each variable and the measure of each angle. So there's a bunch of ways to do this. As long as you get the right answer, you're fine. What I notice is that I have two different angles, two different variables. I have two different variables and it's gonna be really hard to solve for that. So I'm gonna try to solve for one variable first. So I'm gonna ignore the answers and I'm going to look at this. And I'm gonna see, okay, what do I know? One thing that I notice is that this 2x minus y and this 2y are what, guys? They're vertical angles. And what do I know about vertical angles? That they're equal to each other. So I'm going to set 2x minus y equal to 2y. And I'm going to solve for, let's solve for, x. It's going to be harder to solve for x. Okay, so let's solve for y then. So, okay. They really had to generate the hardest question. So, sorry guys. So, let's solve for x. So I'm going to add y. So I'm going to have 2x equals 3y. Divide by 2. So my x is equal to 3 over 2y or 1.5y. That is crazy hard. Okay. Okay. I feel like I'm doing something wrong. All right, so in class, we're going to go over this because I feel like I'm doing something wrong. So let me sleep on it and we're going to go over this problem. So question 63, which is on your test. So we're gonna go over it, okay? So remind me in class to go over it. Okay, yeah, we're gonna go over it in class. 63, question 63. The last one's very simple. How are the angles that form a right angle related? Well, right angles, what are the angles that form a right angle? If I had two angles that form a right angle, they had to be what? Complementary. Because two angles that form a right angle, how many degrees is a right angle? 90. So if angles form a right angle, then they have to be complementary. Okay? So once again, we will review this in class. Let me try one more time just to look at it. So I'm gonna just try to solve it like this and see what happens. So, okay, you know what? Because this is gonna give me a fraction, I'm actually gonna solve it a different way. So I know that 2x minus y and 2y are vertical angles, but setting them equal to each other was kind of a pain in the butt. So I'm not gonna do it like that. Instead, I'm gonna look at another perspective. I'm gonna say that 2y plus x plus y is equal to what, guys? Isn't this just supplementary? Isn't this just a linear pair? So I can also say that 2y plus x plus y is equal to 180. Okay, why is this not going to work? Because what's my problem? I still have two variables, so that one's not going to work either. So let's do one more, and let's look at these two, because these two are also supplementary, right? So let's set these two equal to 180. So 2x minus y plus, right? I'm adding these, plus x plus y equals 180. Okay, now we're solving something, right? Because let's combine like terms. What is 2x plus x? That's 3x. What is negative y plus y? That is 0. So these guys cancel out. So I'm just left with 3x equals 180. Now I'm going to divide by 3, divide by 3. So my x is equal to what? 60. Now, if my x is equal to 60, then I could set it equal to any one of these. So let's do it in red, right? So now, if my x is 60, I can set it to one of these three equations and solve for y. So because I want to, I think this will be easier, I'm going to plug in this 60 onto here. And I'm going to use what I know about this angle and this angle. These two angles are what? Supplementary as well, right? Because they're adjacent, right? And they're next to each other and they form a line. So they're supplementary. So now I'm going to say that what does this say? This says, let's do it in red right here. This says that 2y plus x plus y equals 180. And what did we say x was? X was what? 60. So 2y plus y is 3y plus 60 equals 180. Subtract 60. Subtract 60. 3y equals 120. Divide by 3. Divide by 3. So y is equal to 40. So now, I know that my x is equal to 60 and my y is equal to 40. Is that true? Yes, look. X is equal to 60, y is equal to 40. Now they want me to find, and this part's very pretty simple, straightforward, right? Now they want me to find the measure of each angle. What is the x plus y angle? Well, x plus y, what's 60 plus 40? That is 100. What about the 2x minus y? What is 2 times 60? That's 120. What is 120 minus y? What is 120 minus 40? That's 80. What is 2y? In other words, what is 2 times 40? That's 80. And the remaining angle would be what? So what is this remaining angle? Well, I know that this remaining angle right here is vertical angles with which one? The x plus y. So what was the x plus y? It was 100, so the remaining angle also has to be 100. So we will definitely still review this in class, but I just had to figure it out because there's different ways you can look at it, but there's always going to be an easier way. Okay, so